Right, so just to recap, the law of conservation of linear momentum said that the total momentum before be equal to the total momentum after a collision, right?
Yes, sir.
And what was the formula for momentum?
Mass time. Sorry,
It was being good mass times.
right, mass times velocity, right?
Yes. P is equal to mv. So give problem one a read.
A car heading east at 24 meters per second of mass 1,200 kg collides with a 4,000 kg truck
Wait,
heading west at 5 meters per second. If the wreckage moves as a combined mass, what is the velocity and direction it moves at? First, calculate the total momentum in the system before collision. This momentum should be equal to the momentum of the wreckage after collision. The wreckage mass is the sum of both vehicles. Recall that one of the values for velocity must be negative, since it is a opposing direction.
all right. So we first need to decide upon which one we're going to call negative. Which one do you want to call negative? It really doesn't matter. Once we just need to come up with a convention. You want to let east be negative or west to be negative?
Um, East.
East? Okay. So we could call this negative, right? So we could call this negative 24 meters per second. I'm going to write that over here. So negative velocity means movement to the east. So anytime you're doing these questions, you need to declare which one you're calling positive and negative. Right. So in the question, they said that after the collision, it will be moving as a combined mass, right? Right, Sheena?
Yes, sir.
Now, just by looking at this, which one do you think will have a greater momentum?
The truck.
I think so, right? I believe so. Let me see. 5 by 4,000 is 20,000, yeah?
Yes, sir.
Actually, the car would have more momentum. Watch. It's 24 by 1,200.
Oh, yes, it went
That'll
faster.
be 28,000. Okay, right? So it looks as though what's going to happen is this small car is going, so in the end, the two bodies are going to be moving in this direction, right? But what will happen is some of the velocity will be lost. And so it will be moving at a lesser velocity than 24 because it would have had to overcome inertia, right?
Yes, sir.
Okay. So that's what we're expecting, right? We suspect that the final thing would be moving. We should get a negative velocity. The final answer should be moving to the east. And what would the combined mass be if they're moving as one object? It's one body. What would the combined mass be?
Um, the 4,000 plus the 1,200 kg.
Right, so that'll be 5,200 kg. And we don't know what the velocity is, so we could say x meters per second. So let's calculate the momentum before collision, right? And we know that before collision is supposed to be equal to after. So Shayna, calculate the momentum of the car. What the momentum of the car be?
Of the column, it would be the 1,200 times 24, which is
Not just 24. Remember, we're dealing with vectors here, and sign is very important.
oh, negative.
Negative, right? Negative 24. And then we're going to add that to the momentum of the truck. Right? What's the momentum of the truck?
4,000 kg plus times the 5 meters per second.
Right. And that's supposed to be equal to, we said it would have a mass of 5,200 because it's moving as one body and it has a unknown velocity. So I would say 5,200 by x. Let me know if you're okay with that.
Yes, sir.
All right. 1,200, 1,200 by minus 24 is what?
Um, 20,800.
Right? Minus 28. All right. And this would be 20,000. And that would be equal to 5,200 x. What's the next step?
You'll add your two together. The momentum of the truck and the car.
What do you get?
Um,
Shina? Minus
yes, sir.
28,000
Minus,
plus 2,000.
you'll get minus 8,000.
Right? Minus 8,000. And that would be equal to 5,200 x. So how would I find for x?
You divide on both sides by 5,200.
Right. And you would get minus 8,000 all over 5,200. So the 0 and the 0 would cancel off. So it's essentially minus 80 over 52. What is minus 80 over 52?
Minus 1.54.
Minus 1.54?
Mm-hmm.
And that'll be meters per second, right?
Yes, sir.
Okay. Because of the sign, it tells us that the final velocity is going to be in what direction?
East.
Right. So you could say the combined mass will be moving at a velocity of 1.54 meters per second in the eastern direction. If I'm saying it's moving to the east, I don't need to put the sign.
Okay, sir.
Yeah. All right, so this was easy, okay? Let me know what you think.
Yes, sir.
Problem two. Two
So I
American.
want,
I want to copy down.
yeah.
Okay, no problem. How has everything been in school?
I'm good.
Good. Nice, nice. Nothing stressing you out, right? Or like things stressing you out.
Okay. Um, it's good enough.
Mm,
School is decent. It's good. No.
it's good.
Mm-hmm.
Mhm.
So I'm done. So I finished it down. You weekend.
You finished already?
Mm-hmm.
Okay. Now, I just saying something, right? Now, while this is correct, and nobody can tell you anything because it is correct, if if you did not write a statement, some teachers might give it wrong. It is the standard to say that west is usually negative and east is usually positive.
Okay.
And you're probably wondering why. Think of a number line. Everything to this side is,
Positive.
and everything to this side is negative. So if we're going
Mm-hmm.
in this direction, generally you'd call that negative, right? And
Mm-hmm.
generally you'd call this positive.
Yes, sir.
So be careful and pass statement, right? Okay. Problem two. Two American football players collide into each other. Calculate the velocity the first player will push the second. Okay, right. So I have a question, right? If we want to figure out the velocity the first player will push the second, are they moving as one mass?
No.
You say no?
Sorry, wait.
Let me think.
Yes.
Let me think.
They're moving together. Yes, they're moving one mass.
If this one is pushing this one will be pushing this one, but they come like a clump together. Think about it. And let me just verify the working they had here, but I most believe that's correct. They are clumped together. Yeah, they are clumped together. Because if you understand what I'm saying, like look at them. This one is pushing on this one, and this one is like right against this one. It comes like they're one combined mass.
Yes, sir.
Right, so it already has a statement here before collision and after collision, so you could just jump straight to the working. So for the sake of convention, we are going to say that this is positive, and we'll call this negative, right? Okay. So tell me what you're writing next line.
Um, oh, sorry, we're getting that right. So, in the second line, initial velocity equals final velocity, and we were 90 kg times 5 plus 70 kg by minus 1
And what would that be equal to?
equal to um the 90 plus the 70, so 160 x.
It's well, notice here they're calling it V, yeah? So we should call it V. In this question, didn't really give us didn't really specify, so gotta use X. I mean, either
Yeah.
way, it's correct, right? But you want to make it working as tailored to the question as possible. So if they had called this Z, you would probably want to use Z. So V. Right. And if you're real fancy, you could say VF if you want, because it's final velocity. All this is correct. The main thing is that you do this working, right? So I want you to simplify the left-hand side. Tell me the final answer. So we have 4,500 minus 20. What's in? We have 450 minus 280. Let me know what you would get there.
We found it was 170. Or
170,
do you want to this step right after that? Okay, good.
right? And this would be 160 V. So what would V be equal to?
170 over 160.
Right, what is 170 over 160?
1.06.
1.26
06.
and meters per second. So let's write a little statement, right? The first player they wanted us to find the velocity. So the first player will push against the other player with a velocity of 1.06 meters per second. And you could say that that means to the right. So, Jenna, I see any question how they told you it was 5 meters per second to the right, and they told you it was negative to the left. Like I
Mm-hmm.
said, that's the sign convention. That's like the standard. That's what is standard. They usually say positive to the right and negative to the left. If you're doing something else, just write a statement to let the examiner know what you're doing. That's what
Yes, sir.
you're working.
I also have it already.
Okay, cool. Right, so let's do these two questions. Actually, I'm gonna give you take take 6 minutes and do these two questions. Take 6 minutes and do these two questions.
All right, so
All right, China, how is it going?
I'm good to start my second one.
Okay, cool. All right, Sheena, so the time is up. All right.
So, so I know, but like I almost done. I want to finish this question.
Okay, okay.
Okay. So I in 10 now. Well, like when I took a picture now.
All right, let me see what I have here.
So I don't know if the explanation goes with this one, but yeah.
All right, so the law of conservation of momentum states that total momentum before collision is equal to total momentum after collision. Due to the total momentum before the collision, zero. Hmm. Okay, this sounds it sounds
So
correct, but I feel like you had to explain it a
I
little
don't
better.
know.
You
Okay.
had to explain it a little better. So these two cars have the same mass and they're traveling at the same speed towards each other. If it's towards each other, that means they're going in opposite direction, right?
Yes.
So essentially what's going on here is that we have this situation. One of them have a momentum of mv and the other one have a momentum of minus mv. So when you work that out, you're going to get zero. And we need to write a statement for that, right? So I'm going to tell you what you're supposed to write, like a proper answer. But your answer wasn't too bad. So before the collision, the two cars have equal, right? So the two cars have equal but opposite momentum because they have same, right? Same mass and speed. So before the collision, the two cars have equal but opposite momentum because they have the same mass and speed, but are moving in opposite directions. Right? And to summarize this, you could say m by v plus minus m by v, and that'll be equal to zero, right? After the collision, both come to rest. Right. Since total momentum remained zero, before and after the conservation of linear momentum The law of momentum. So let me read back your answer one more time. I believe it had this. You said, so in the answer, it kind of had to see what you're seeing because of the pencil. But I'm going to read what you see and you will tell me if that's what you have, right? The law of conservation of
Mm.
momentum says that the total momentum before collision is equal to total momentum after collision. What would they say in there? Due, due,
Uh-huh.
due to this, the total momentum before the collision would be zero. Okay, that wouldn't be why. You're saying, okay, so you're saying because of the law of conservation of momentum, that the total momentum before would be zero. No, that's not why. It would be zero because the two cars have the same mass and speed, but are moving in opposite directions. That is why the momentum would be zero. Not because the law of conservation of momentum. Try to understand what I'm saying there. You understand what I'm saying?
So I was always saying, but the
Because
reason why I did say why I say is because the collision before is equal to collision after, and the collision after would have been zero. So yeah.
let's say that again.
Sorry.
Wait, let me read out the whole thing you're saying.
So okay.
Due to this, the total momentum before the collision would be zero, and the total momentum of after the collision would also be zero as the cars come to rest. Okay. I still feel like it could be a little better, and it could include the equation, right? But how much marks I'll give you, boy, if I was to mark this? You see, you leave out this important part, right, Sheena? You left out the part that they had the same mass and speed but moving in the opposite direction. So it'll be mv plus minus mv is zero. That's the real reason. That's one of the main reasons, right? You had to say that. And that would be zero. So after the collision would be the same thing. So it conserved the momentum because before is equal to after. I would give you 3 marks. Yeah.
All right. Then.
All right. Let's do C. A projectile of mass 0.12 kg is fired at a stationary block of wood of mass 4.5 kg. The projectile embeds itself in the block of wood and they both move off with a velocity of 4.2 meters per second. Calculate the velocity of the projectile just before striking the block of wood. Okay, we might have to do some algebraic manipulation here. So let's draw a quick diagram. Right, so we have a projectile here, right? And we fire this at a block of wood, right? And what's happening afterwards? Shina, after the collision,
I'm
what's
sorry,
happening?
sir. Both move.
Say that again.
They were both move. In question, I took on the velocity.
So how should I draw my final diagram?
Um, the 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 thing would collide with the block of wood, and they'll move together.
Okay, tell me this is what you have in mind. Like this?
Yes.
Okay, yeah, that's fine.
Say it to me a second, guess it was.
Give you a second.
No, I was saying just having a second guess and nice.
I'm not hearing you properly. Let me raise the volume. Yeah, try talking now.
No, no, I was saying that you just have my second guess in this house.
Oh, if you think something is right, say is right. Don't let me second. Don't let me make you change your mind. If you believe in something, tell me what you believe in, right? Sometimes I might be saying things wrong on purpose to see if you're going to actually correct me,
Um,
right?
okay. So
Because
you
that
see, you shouldn't do that because I would think that my answer wrong
no, you
and
you
you're right.
have to
So,
you have to be confident in whatever answer you say. Like whatever answer you say, you must have a reason for it. Clearly, is whether it's the right reason or not. But just whatever answer you have in mind, just be confident in it.
okay.
All right. So this projectile here, right, has a mass of 0.12 kg. We don't know what the velocity is, right? We don't know, right? The block of wood has a mass of 4.5 kg, and we know that its velocity would be, how much you know, what would the velocity of the block be?
What I say, yeah, it would be the block,
Yeah, the block,
0.
right? 0 meters per second because it's at rest. And this projectile, and we could both agree that it's moving in this direction.
Yes, sir.
And the reason for that is because at the end, they said it moved off at a velocity of 4.2. If it's positive, the standard says that it's moving to the left or to the right. What does the standard say? If it's positive, you're moving to the left or to the right. Shina, if you have a positive velocity, does it mean you're moving to the left or to the right? Right. And then here, if you're talking,
When start positive, verify it.
if it's positive, it going to the
Right?
right, correct, right? And if you ever forget, just think of a number line, right?
Mm-hmm.
So the final thing will be moving at a velocity of 4.2. And what would the mass be?
It would be the 0.12 plus 4.5.
Right. So the 0.12 plus 4.5. And what would that be equal to?
4.62.
Right. So now we can do our calculation. So total momentum. Okay, cool. So before, it's going to be m by v. So it's going to be 0.12, right, by v plus 4.5 by 0. And that's going to be equal to the mass of 4.62 by 4.2. Right? Now, if in your working you didn't draw the diagram and instead you decided to add over here, that's great. That's okay. So it's going to be 0.12 V plus 0. Anything by 0 is 0. And what are we going to get on the right-hand side? What's 4.62 by 4.2?
19.40.
19.40.
40.
Okay. I see you have 19.404. You use that's okay. I would actually advise, like when you're doing these multi-step calculations, right, Shina, I would advise that you store the value, or since you would have the value right after the calculation, take that value and divide it by 0.12 one time. Don't use the rounded off value because
So it's
every
not rounded
time
up, it's 19.404.
it don't have any other points, it's just literally 19.404.
Yes, sir.
Okay. But when you're doing multi-step calculations, try to use the exact value. Right? I understand here that 19.404 is the exact value, so that's good. Then we would divide both sides by 0.12. So V would just be equal to 19.404 divided by 0.12. And what did you get?
Um, 161.7 meters per second.
Okay. So that answers our question. So the projectile was moving at a velocity of 161.7 meters per second. You okay with this question?
Yes, sir.
All right, nice. Let's move on. So forms of energy. This is stuff to read, right? So we could go through this quickly, right? So energy, you need to know what energy is. Believe it or not, sometimes they ask you to state the definition of energy. So energy is just simply defined as the capacity for doing work, right? The unit for energy is joules. A joule is defined as the work needed to move 1 Newton by a 1 meter distance, right? So the SI unit and the fundamental unit for joules is Newton meter. You knew that, right?
Yes, sir.
And you know the formula that work is equal to force by distance,
Yes, sir.
right? So force is newtons and distance is meters. So the fundamental units for energy is Newton meter, and the SI unit for work done is joules. And you remember the difference between fundamental units and derived units?
Yes, sir.
Okay, cool. Do you think joules would be a derived unit or a fundamental unit?
You're right.
Yeah. So the principle of conservation of energy states that energy can neither be created nor destroyed, but can only be converted from one form to another. So you need to know this. I presume you'd hear this in school already, right?
Yes, sir.
Okay. And we have different types of energy here. Um, you could read up on this after, but the main ones we need to look at in physics is mainly kinetic and mechanical, gravitational potential, and elastic potential. The other ones, not so much, right? You will also see nuclear when we're doing nuclear physics, making bomb and thing, and you wouldn't really see electromagnetic, right? But the main thing you need to know about is kinetic and mechanical. Let me just test you. Do you know the formula for kinetic KE? Do you know the formula for kinetic energy? Do you know how you would calculate kinetic energy, Shina?
Do I remember this? This is I know potential was mass times gravity times height.
Mm-hmm.
Magnetic. Um, I don't think I can remember that. Wait, it was a half times
Half,
mass
yeah?
velocity. Where?
Yeah, half mv squared. Mm-hmm. Half mv squared. Good job, right? You remember it. I said these are the main ones you need to remember in physics. All right, so let's move forward. So I want to explain something, right? Do you think we just agreed that energy can neither be created nor destroyed, only converted from one form to the other? So check this, right? If we have a ball on top of a shelf, what kind of energy do you think it possesses?
Potential.
Right. Now, potential energy is the amount of energy a body possesses by virtue of its position relative to the ground, right? So it has some distance from the ground. Now, if it rolls off the shelf, that potential energy gets converted to what?
Kinetic.
Right, because kinetic energy is the energy by virtue of motion, right? Is when something is moving. So energy is always converted from one form to the other, right? Okay. So energy, oh, I reading for. Shina, give that a read for me.
Energy can either be released or stored, and it is used or released to produce some type of change is termed work done. Work has the same unit as energy. However, even though energy can be stored, work cannot, so these terms should not be used interchangeably.
Right. So you're not going to, okay, so you remember when you were doing moments, right? Remember that?
Yes, sir.
What's the formula for moments? Moment. Moment is equal to what by what?
I have to remember this. What,
If you hint, right?
um,
Moment is the
um,
amount, moment is the amount of work.
it was, um, force by distance.
Yeah, and as we know, force by distance is the formula for work.
Mm-hmm. So
Yeah.
I'll keep you remind me, the rules for the system in equilibrium. Like, when you ask that, I was thinking about that right for me.
What formula you think I was talking about?
No, no, no. I didn't think it was a right formula, but when it mentioned moments, the two like like the conditions for assistance in equilibrium came to mind when the formula of that.
Oh,
See.
like the downward force must be equal to the upward force something.
Mm-hmm. Yeah.
Oh, nah. Talking about the formula, right? So
So I don't know, I was just saying that came to mind before the formula.
okay, right? So that's where it should come. That's where it should ring a bell, right? Because work is equal to force by distance. Moment is also equal to force by distance. Because moment is the amount of work you would need to turn something. Yeah. So W is equal to F by D. Please remember this. F is force in newtons, D is distance in meters, and W is work done, so that's in joules. Right? In moment, when you do a moment question, moment, the units for moment is Newton meter. You will not use it interchangeably like they said, right? You cannot say it's joules, right? It's Newton meter. All right. Um, power. Power refers to the rate of energy conversion or work done over time, right? So for example, if there are two sprinters of the same mass, 70 kg, who run the same 100-meter dash, but sprinter A completes the race in 1 minute, while sprinter B completes in 1.5 minutes. Both sprinters did the same work, but sprinter A had more power than B since he did the work in less time. So Shayna, the work in this example would be to complete the race. Did both of them complete the race?
Yes, sir.
Yeah, but who did it faster?
Sprinter E.
Sprinter A. So Sprinter A would have had more power because both of them had the same mass. So that's not a differentiating factor, right? So the differentiating factor would have to be speed, right? So make sure you have this formula copied down. W is equal to F by D, right? And P is equal to E over T. And as well as the definitions. So you should tell you we should have copied down. Yeah. Right. So make sure you have, you're right, you wrote that energy is defined as the capacity for doing work, right? You need to know its units, its joules. The fundamental units is Newton meter. You need to know the conservation of energy, right? So copy that down quickly. Jada, see that you just joined. Um, is everything all right?
Sort of. I could ask you to stay back after class and I'll explain everything.
Sure, not a problem.
Thanks.
Sabe, capitão?
Okay, good. Right? And you also should copy down that. So copy down this. Make sure you have this formula for energy, right? So W is equal to F by D. So work is equal to F by D. That's the formula for work. Right? Make sure you have the formula for work, right? Make sure you have the definition for power and they have the formula for power. Right? So have the formula for work, have the definition for power, and have the formula for power. All right, so Shina, do you have the formula for work copy down as well as the definition for power and its formula?
Yes, sir.
Okay, nice. All right, so input, output, and efficiency. By the way, Jira, are you copying down notes or you in work right now?
I am in work, but I'm making small notes.
All right. Okay, so input, output, and efficiency. So efficiency refers to the percentage of useful output compared to the total supplied input, right? Um, Shina, when you're charging your phone, right, does the charging block get warm?
Yes, sir.
So does that, so okay, isn't heat a form of thermal energy, which is in general a form of energy?
Yes, sir.
Okay, is that energy? Is that heat charging your phone?
No, no.
No, the heat not charging your phone. So then is energy being wasted? Think about it. If the main
No.
goal of your charger, if the main goal of your charger is to charge your phone, right? And all the energy should go from the block to your phone. It shouldn't have heat being produced. So that's not useful energy, right? That's energy that's being wasted. So efficiency is defined as the useful output over the total input. So Shina, let's just say your charger is 45 watts. Did you know that power is measured in watts?
Yes, sir.
Okay, let's just say your charger has a power of 45 watts. Let's just say only 37 out of the 45 is being used to charge your phone, right? And the rest, which is 8 watts, is being produced as heat. How can we calculate the efficiency of this thing? Like without even looking at the formula, how do you think we could find the efficiency of this thing? What do you reckon? What do you feel we would do?
Sorry, repeat. So 45 is what?
The charger says that that's the power it uses from the outlet.
Mhm.
So when you plug it into the outlet, it takes up 45 watts of power.
Okay. And
37.
it's charged,
Yeah, tell me.
and it's charging, and it's only using 37, and the rest is heat energy being wasted.
Yes, precisely.
Okay. Um,
How efficient is this thing? How would we calculate how efficient it is?
45 over
Nah. Not 45 over. Think about it, right, Sheena? If we want to see how efficient this charger is, we want to compare what two things and in what order.
or it would be the 37
Mm-hmm.
over 45,
Yes. And you'd multiply that by
100.
right to get your answer as a percentage. So that's essentially the formula. The formula is just useful output over the total input by 100%. Right? So you copy that down. So efficiency is equal to useful output over total input by 100%. Right? So as soon as you have that copy down, let me know.
Stop it.
Okay, nice. And so your answer for this, like if you want, you could just for an example, and the example for this would just simply be the 37 all over 45 by 100. And how efficient would that be?
82.2. Well, 2.
Hmm? 82,
82.22.
right? 2.22%. Nice. And for power, you copy this down too, right? Just making
Yes,
sure.
sir.
And you wrote the formula. You wrote what P stood for, E stood for, and T stood for.
Mm-hmm.
Okay, good. Jada, you understand this concept of efficiency?
Yes, I do.
Okay, nice. So you understand you could be putting in plenty energy, but well, not say sure, but you could say energy, right? But power. It could be supplying a certain amount of power to something, but only some of the power is actually being utilized to do what you want it to do. right? Some of it is actually being wasted. So to find the efficiency, it would simply put the amount that's useful all over the total amount of power you use and multiply by 100%. Yeah. All right. So you understand that, right, Jada?
Yes, I understand.
Okay, cool. So Jada, do you know about potential and kinetic energy?
Yes, I remember those terms.
Okay, let me do a little recap on what both of them are, right? So kinetic energy is the amount of energy an object possesses by virtue of its motion. So if something is moving, it would have kinetic energy. And as such, the formula will contain velocity in it. So kinetic energy is a half m, which is mass by velocity squared, right? Now,
Right.
potential energy is the energy something possesses by virtue of its height, right? Because Jada, if something has a height, wouldn't it be attracted to the ground as a result of gravity? So it would have the full thing is gravitational potential energy, but we did just say potential energy. So if something has a height and it has a tendency to fall down,
Yes.
right? So the formula for this would be mass by gravity, because gravity is going to cause it to accelerate towards the ground, right? By height. So that's just a little recap. So if something is not moving, its kinetic energy is zero, right? If something has a distance away from its resting position, it's going to have potential energy, right? So let's observe the energy changes in a pendulum. All right. So Jada, if I have a pendulum in that state, right? In that state, is it moving?
No.
No. Okay. Let me let me rephrase that. Right? Imagine it took so depend and we could both agree that the pendulum would start off in this position. Yeah.
Yes.
All right. If we take the pendulum and we were to pull it over here, right? What type of energy do you think it has? So we have not released it yet. What kind of energy do you think it has? Kinetic or potential? So we displaced it from the resting position. And so think about what kind of energy it would have.
Potential energy.
Right. It has potential energy because as soon as you release it, that potential energy gonna get converted to what? What is it gonna convert to?
Kinetic.
Right? Because it's gonna start to move. Nice. So let's look at the changes here. So when you pull it forward and you put it at position 1, it's going to have the maximum gravitational potential energy, but the minimum kinetic energy because you have not released it yet. At part 2, the gravitational potential energy is being converted to kinetic energy. At 3, what is happening is that we have the minimum gravitational potential energy and maximum kinetic energy. Jada, if you're confused about that, think about it like this. So if you let go of it here, wouldn't it swing to this position and then come back?
Yes.
Okay, if it swings, so when it makes a full swing and it reaches at this position, what's the kinetic energy? So tell me, Jada, when it reaches over here, it's going to stop for like a split second, right? And it essentially comes like this scenario over here. If it reaches here, and isn't it going to swing back eventually? It's going to swing back
Yes.
eventually. So if it's going to swing back, what's causing it to swing back? What kind of energy? So when you let go of this thing, it's going to swing here and it's going to stop for like a brief moment in time. So if it stops, what energy does it not have? If it doesn't move for like a brief point in time,
Kinetic.
right? So at this point, it doesn't have kinetic energy, right? It has gravitational potential energy because it reaches its maximum displacement, right? If it displays something to the maximum amount, well, it would swing back. Would swing back. So Jada, you understand? Let me run through your whole process again. At stage one, it's going to have maximum gravitational potential energy, but little to no kinetic energy because it's not moving. Tell me if you understand that.
Yes, I do.
Okay, in stage two, you would have let go of it, right? But not all the potential energy would have been converted yet. And why is that, Jada? Well, it's because it's still some distance away from its resting position. Isn't this a resting position?
Yes.
So here I was saying, Jada, once it have some distance away from where it would rest, it has gravitational potential energy. So at stage two, there's still potential energy, but it's being converted to kinetic energy. What about if I add in stage 2.5? Does that have potential energy?
Yes.
Yes. But when it reaches its resting position, it isn't oh it isn't okay, think about like height, right? If we're talking about height as the distance between the resting position, if it reaches at the resting position, there will be no potential energy because it's at the resting position. There's no distance away, so height will be zero. That makes sense?
Yes, it does.
All right. And it would keep on swinging, right? So as soon as it swings past the resting position, it's going to get back some distance away from the resting position. And it's going to start to build back potential energy, right? So that's why in stage four, you're seeing the kinetic energy is being converted to potential energy. And at stage three, you have the minimum potential energy and the maximum kinetic energy. Because like we said, at this stage, it's at the resting position, so it has little to no potential energy, right? But it has a maximum kinetic energy, right? And when it's swinging here, the maximum kinetic energy will be converted back to potential energy. And eventually, when it reaches here, what would happen, Jida? What would happen when it reaches here?
The kinetic energy would be turned into potential energy.
Right, so you would have the maximum potential energy. Because, Jida, at this position, it's at the maximum displacement from the resting position. It at this point, it doesn't get further away from the resting position. You understand what I'm saying? Like,
Yes,
like it still have more it could go. So this is the maximum displacement. It doesn't go further than that. So this is where it would have the maximum potential energy. Right? And the whole process just repeats again. So there's that energy in a pendulum. And you need to know the energy conversions and what's happening at each stage. Shina, do you understand this perfectly?
Yes, I understand.
All right. So let me pick you up, right? What would happen at stage 3.5? Tell me, Shina, at stage 3.5.
3.5.
Yeah, I just called it that. In between.
Okay. You would have like a low amount of potential energy, but a high amount of kinetic.
Okay, but would I have the maximum kinetic energy?
Yes, sir.
No.
Well, 0.5. No, it would be 3.
This That one,
Two.
3, 4, and 5, that's not that just refers to the stages, That don't have nothing to do with the energy, right?
Right.
All right, so Sheena, just remind me, where would I have the maximum kinetic energy? At what stage?
22.
At where?
Stage 3.
So do you think I would have the maximum kinetic energy over there or a little less?
Of this.
Right. Yeah. Okay, good. And over here.
You would have your maximum potential energy and
Mm-hmm.
the minimum kinetic energy.
Nice. Great. I presume you're not copied this already, Jens.
Um, just now.
Okay.
It's really good. Yeah.
Okay. You have everything copied down?
Yes. Sir.
Right. Right. So I would have told you all what kinetic energy is. So this is the energy possessed by an object in motion, right? So Ke is equal to half mv squared. Great, we know that. Potential energy is the energy possessed by an object by virtue of its position or height. We would have discussed that. We know that. Right? And you need to know the kinetic and potential energy conversion. So when an object is falling, right, assuming no air resistance, the following is noted, right? So Jada, check this, right? I have a ball here on top of a shelf. Jada, tell me, what kind of energy do you think that ball has?
In its current position,
Mm-hmm.
potential.
Does it have any kinetic energy?
No.
No. But if it rolls off and it reaches over here now, it's going to fall. So in other words, this potential energy, so the potential energy lost, right, gets converted to kinetic energy gained. Tell me if you understand that. So by the way, Jada, we can't create energy. We is not God. We can't create energy. We can't destroy energy either. It just gets converted. So the potential energy here, right, it's gonna get converted to kinetic energy and it's gonna fall. Understand?
Yes, I do.
All right, nice. So that's why we're seeing GPE lost is equal to KE gained. Right? For situations that account for resistance or friction, energy loss is accounted for. Example, a cyclist has a cyclist and his cycle have a mass of 70 kg. They descend a slope from 2100 meter point to the 1600 meter point. Assuming that 75% is lost to friction, what is the velocity of the cyclist as he travels down? Let's try this question, shall we? Seems like an interesting question to try. Right, so Shane, wait, help me with this question, right? So before we start, Selma, what's all the formulas we know? What's all the formulas we know? Tell me, Shana, what's all the formulas we know? Tell me.
Like what we just learned, or
Related to the topic. So we'll start off with kinetic energy.
oh, okay.
What's kinetic energy?
A half times mass times velocity squared.
Right? What's potential energy?
Mass by gravity by height.
Great. And if something Okay, and let me give you the easiest example, right? If you had a ball here, and so at this point, it has potential energy, right? No kinetic energy. But when the ball starts to fall, the potential energy gets converted to kinetic energy. So you will lose potential energy and you will gain kinetic energy. So we understand that. So,
Yes, sir.
Shina, I want you to read this question and I want you to tell me what's happening here. Tell me, will there be any energy changes?
Um, for situation that account for resistance and friction, energy loss is accounted for. Example, a cycle is on a cycle of a mass of 70 kg. The descent is slope from a 2,100 meters point and 1,600 meters point, assuming that 75% is lost to friction or cell velocity to cycle. Oh, okay.
All right, so tell me this. So let me just draw a little diagram, right? Do clong me here. I'm gonna try something. What? I need to draw a bicycle. Do I remember what a bicycle looks like? Um, um, you're gonna call that. All right. Sheena, this is a wonderful work of art.
Yes, it's very, very beautiful.
All right. All right. So according to the question, right, Sheena, um, we have a cyclist and they are telling us the mass of the cyclist and the cycle. So altogether, these things have a mass of what? What's the mass of both of them?
70 kg.
70 kg. And oh, where are they right now? Like what height from the ground? If we call this the ground, right? What height are they at right now?
With descent slope. The 2,100 meters point.
Right? That's correct. So they clearly possess what right now?
Potential energy.
Right. And then they're saying they're going to descend the slope from 2100 to
1,600 meters.
right. Wait, boy, this looking professional here, boy. Hey, I'm gonna become an artist. I'm gonna become an artist. Hey, boy.
That's
Right. It's looking like hill climb racing here. I don't know if you know about hill climb racing.
yes, so I was pronouncing that.
Oh, I surprised you know about hill climb racing because only like young. Well,
So we're not that young.
okay.
Well, we are, but yeah.
All right. 1600 meters will be over here. So this man clearly possesses potential energy, right? So there's clearly potential energy. So, Shina, don't we know that the potential energy would get converted to gravitational? What's in? And we know the
Kinetic
potential
energy.
energy would be converted to kinetic,
Yes, sir.
right? Guys, I need all you to understand that potential energy means the same thing in most, in, I could just say the same thing, right? Literally, for all intents and purposes. Potential energy means the same thing as GPE. They mean the same thing. So potential energy and gravitational potential energy means the same thing. Why? The whole reason potential energy exists is because of gravity. Shina, if you was in space, right, would you have potential energy?
No.
No, because you don't have gravity, right? And in space, if I plop you somewhere in space, right, or just put you somewhere in space, and you would just stay there unless something hit you.
Yes, sir.
Yeah, that's what depressing. All right, what's the formula for potential energy? We just wrote it,
Mass and gravity times height.
and that would be equal to the kinetic energy. Half mv squared. Now, in this question, right, Sheena, they are saying that 75% is lost to friction. 75% are what? What is being lost to friction?
Of the energy.
Exactly. So if 70% is being lost, how much potential energy would actually remain?
If 70, you see? As well as 75, was it?
Sorry, 75. If
Right.
75% lost, right?
25.
75 is lost. 25% remains, right?
Yes, sir.
So enter would just have to find 25% of mass by gravity by height, because this would give us total energy, right?
Yes, sir.
So 25 by mgh is equal to half mv squared. What's the mass in this case?
70.
70. Let's, for simplicity's sake, let me just use gravity as 10, right? And what is the height? What is the height? Let me see if we
Height
can
would be
figure out this one.
2,100 minus
No.
the 1,600.
Oh, minus. Yes, 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 yes. Right? Good on you for seeing that. Jada, you think you understand why we see in 2100 minus 1600?
Yes.
Because that's the height he's traveling. Like that's the height. The height. The height is actually, and if you subtract that, we're gonna get do some mental maths.
5.
Right. $5 or 500?
500 meters.
I now say I don't want you to count my money. Next thing I ask you how much money I have, and you tell me $5 and I have 500, right? 500 meters. Great. And that's supposed to be equal to half mv squared. Now, what's the mass? Again, the mass is 70, and we don't know what the velocity is. So we'll just put v squared, right? So 25 over 100, that's going to be by 70 by 10. Simplify the inside, it's 500, and that's going to be equal to a half mv. Right? M is 70 v squared. Right. Shane, are you ready to simplify everything?
Yes, sir.
Okay, great. So in the calculator, we could plug that whole thing in like wholesale. Plug that whole thing in. You don't even need a calculator, right? You do this mentally. So 70 by 10 is 700, right? So 700 by 500 is 35, right? Just verify that.
Yes, sir. Yes, sir. Okay.
All right. And then you would divide that by 100. So cancel off this, cancel off this. And then you'd multiply that by 25. So if I multiply 25 by 35, 875. So like 875 zero zero. Just let me know if you're getting that in the calculator.
Yes, sir.
Okay, nice. So that'll be 87500, you get?
Yes, sir.
And that would be equal to half of 70, which is 35. So now we need to make V the subject of the formula. So how would I make V the subject of the formula?
First you divide both sides by 35, and then you to the square root of both sides.
Right. First, I would divide both sides by 35, right? So V squared would be equal to, that's 887,500 divided by the 70, and you should get 1250. No, what's it? 500.
2,500. Yeah.
Then you would find the square roots. All right. And you should get 50.
Yes, sir.
Nice. Let's just check the answer that they got, right? They got 50 meters per second as well. Nice. So we think about this question, Sheila, easy or hard?
I think it's easy.
I think so too, right? But we need to understand why we said this. Why did we say that? Why did we multiply the total potential energy by 25 over 100?
Because it was 25% for the potential energy.
Right, because we lost 75%. Right, so we lost 75% of the potential energy. So only 25% remained. Nice. Okay. I'm gonna take a picture of this drawing. This drawing is world class. Like this should be in a museum somewhere.
Yes, yes, definitely. Because she's something in the arts.
I see that. Ah, nice. All right. So yeah, I'll copy this down. Right, this is the full detailed working. I'm not sure if you can see everything there. Might
Yes.
need something to see it. All right, so Jadon, is nice to finally see. I didn't see it in a while. Right? I'm sorry to hear about what happened, but I'm happy that you're here. Right? Is everything okay with you? Other
Yes,
than that?
I just very tired, but pushing through.
Okay, good. Maybe I'll see you gotta push through, right?
Yeah.
Can't do anything else.
Huh?
I say you can't do anything else. You gotta push through.
True that.
All right. So while they're copying on this question, I will just explain it to you quickly, right? So
Yeah.
we're doing energy right now, and the two main types of energy in physics we need to look at this level is kinetic energy and potential energy, right? So Jadon, you should know that you can't destroy or create energy, right? Energy just gets converted from one form to the other form. Right? So energy is converted. If you're losing one kind of energy, you're gaining another kind of energy. So let me give you an example. Um, if you take your finger and you rub it against asphalt. I don't know why you would do that. You hit yourself probably. And by you moving your hand, that's mechanical energy, and you would lose that energy to friction, and wouldn't your finger heat up?
Yeah. Yeah.
So the mechanical energy gets converted to heat energy, right? Because it loses some of the energy to friction, and that results in a conversion to heat energy, right? So energy is always converted, always. Another example would be like if you drop something on the ground, wouldn't that energy? So if you drop something, it's going to be kinetic energy, and when it hits the ground, it's going to produce sound energy. So energy is just converted from one form to the next. That's why you would have seen me wrote potential energy equal to kinetic energy, because the potential energy would be converted to kinetic energy. So they had to be equal. That's one thing you should know. And you should know the formulas. Right? Kinetic energy is energy something has if it's moving. If it's moving, it have kinetic energy. And if something moving, it would have what? What would it have if something is moving?
Potential energy.
No, if something moving, it would have velocity.
Oh,
Think about it. Velocity is if I tell you something have velocity, what do you think about it? If something has velocity.
it has speed.
Yeah, if something has speed, it means that it what? Staying still or moving.
Oh, it's moving.
Right. So kinetic energy needs to have velocity in it because it is the energy something has if it's moving. Right? Potential energy is the energy something would possess by it being a height or it being displaced from the ground or resting position. Let me explain. If you have a ball on top of a shelf, and if the ball rolls a bit, and it would fall down and it would go towards the ground.
Yeah.
Right. But this ball in its current position has potential energy because of its relative position to the ground. That's what's going on. Right? So because it has some height away from the ground, it has potential energy. And potential energy works because we are on Earth, and Earth has gravity.
Yes.
Right. So if anything falls, wouldn't it be okay? The reason why things could fall in the first place, and that's because of gravity, and gravity attracts things towards the center of the Earth, gravity.
Yeah.
Right. So because of gravity, you have something called potential energy, right? Because if you have something on a platform, right, because of its height, it could fall. And if it falls, it will be accelerated towards the ground because of gravity. Does that make sense?
Yeah.
You think it have potential energy in space?
No.
No, because what's the gravity in space?
Zero.
Zero. If I take you and put you in space, will you be falling down or will you stay in the position you're in?
Stationary.
Exactly. So potential energy exists because of gravity. Now, in this question, they are telling us we have a cyclist here. My amazing drawing. We have a cyclist, and the cyclist right now is 2,100 meters away from the ground, right?
Yeah.
He then cycles until he's 1,600 meters away from the ground. So what height he traverse? What height? So from 2,100 to 1,600, what height did he traverse?
500 meters.
500 meters, right? So that's the height. So Jaden, do you understand? Because of the cyclist's height, he would have potential energy because he's not on the ground, right?
Yeah.
Don't understand that. Right.
Yeah, I do.
So potential energy, right? You're probably wondering why I put 25 over 100 and I multiplied by that. Well, they're saying assume 75% is lost to friction. If 75 is lost to friction, how much energy remain? What percent remain?
25.
Exactly, right? And 25% is 25 over 100. So that's why I see my right 25 over 100 by mass by gravity by height. Yeah. The mass in this case is 70. Gravity we call 10 because we're on Earth. And the height would be 500 meters because that's the height traversed. Right. And we are saying that that would be equal to kinetic energy because as he goes down, the height gets smaller and smaller and it gets converted to kinetic energy because he starts moving. Right? He starts moving. Anytime you're moving, you have kinetic energy. So I put these two equal to each other and I end up with this equation here, 25 over 100 mass by gravity by height is equal to a half mv squared. That's the formula for kinetic energy. So I plug in all my values, right? The only thing I'm missing is v. So I make v the subject. I end up with v squared. The opposite as squared is square root. So I square root and I end up with 50. So the velocity is 50, right? That's what they wanted us to figure. What is the velocity of the cyclist as he travels down? So as he travels down, Jadon, that potential energy gets converted to what?
Kinetic energy.
Right, because he starts moving. If you're moving down a hill, you'll start to speed up. That's kinetic energy. Say potential energy gets converted to kinetic energy.
So I guess by logic, if you're going up a hill, it's switched or flipped.
Say that again.
Meaning, if you're like going up a hill, is it flipped or is it like so like? Well, obviously not. Hold on.
I understand where you get to that, right? You're asking me if you're going up a hill, would it change? Like would the because in this instance, the potential energy is getting converted to kinetic energy. That's what you're saying. Like that's what you're saying. So you're asking me if you're doing the opposite, would kinetic energy be converted to potential energy?
Yeah, that's what I'm asking.
All right. Yes. Think about it like this. Imagine if you're going uphill instead, right?
Yeah, well, yeah,
If you reach here, if you reach at this point, you would need some kinetic energy to do that,
some speed. Okay,
right? And if you stop here all of a sudden, if you stop at this point, you stop, wouldn't you now have potential energy? You'll fall back down?
yeah.
Yeah. It's a good
I
question.
kind of had an instant with that like last night when I was like coming back home. We were driving up the hill and I was following behind my cousin and she like I guess took some speed before she went up the hill so she could she wouldn't be like lagging on the hill itself. So I guess the kind of this scenario actually play into it, from what happened said as well. So that's kind of cool. Yes.
Physics in real life.
Yeah, physics.
Because physics is real life. Huh.
True.
Physics is real life.
Yeah.
Right? So everybody understand the energy conversion and how we get V. Now,
Yes, sir.
now,
Yeah.
not all the time we would have friction. A lot of times in physics questions, you would see assuming no energy loss to friction. If that is the case, you would not say 25 over 100. You would just simply say M by GYH. That's what you would say. No 75% loss. So you don't have to do the 25 over 100. But in this question, it's specified that some was lost. So be specific. Okay. Right. So on to the boring part. This is not really physics, but I guess you have to know it anyways, for whatever reason. Yeah. So, guys, Shina, I want to read that for me.
Okay, so just the first one.
Read everything.
Okay. Alternative and renewable energy sources. Fossil fuels are formed when the remains of decayed microscopic organisms, animals, and plants from millions of years ago that have been pressed and subjected to hot temperatures over long periods of time. They mainly come in the form of coal, crude oil, or natural gas. Fossil fuels are finite resources that cannot be replaced and are said to be non-renewable. In addition, the combustion of fossil fuels has, however, had negative effects on the environment, such as the greenhouse effect, due to the release of carbon dioxide by combustion, and acid rain due to the release of sulfur dioxide into the atmosphere. Energy sources that are infinite can be replaced and termed renewable, and can be used as viable alternatives to fossil fuels. Note that the sun is the main source of energy for all of these, except geothermal and nuclear.
All right, so that we understand what all of that mean. Basically, it have non-renewable energy and I have renewable energy, right? Shina, you think non-renewable energy is infinite or it'll eventually run out?
Is this?
Infinite. Non-renewable, eh? Non-renewable. What is
Oh,
non
it's finite. It is finite. It
this
will eventually run out.
because it's non-renewable. You can't renew it. You can't replace it. So it come like you're using up a certain amount of money in the bank. Right? Eventually you go have no money. Jadon, you understand that? I show you I show you know about non-renewable and renewable energy. Feel like you know.
Yeah, does like normal um like base science
Yeah,
and
yeah.
greenhouse effect and greenhouse gases.
This is not too fancy, right? Non-renewable is finite, renewable is infinite. Right? Give us some examples of non-renewable energy.
Non-renewable energy. Um,
How about F? F. We just use it in the Caribbean. F. FO.
F by
Yeah,
FO.
yeah, FO. My aunt's in the background, tell them what the answer. Hollywood energy. Right? Yeah.
Oh,
Jadon.
fossil, like
Yeah.
fossil, that is.
Fossil fuel. Fossil fuel. Yeah, fossil fuel. Yeah, I had to hear that one year. I hear that in second. I'm in primary school and thing.
Yeah.
Fossil fuel. All right. Okay. Give me an example of renewable energy. I have plenty. We have renewable energy. But we just don't happen
Okay,
to be
well,
using it.
um, wind,
Wind, yeah.
water,
All right. So hydroelectric.
sun, well, solar,
Solar, all
and
right. Should have a good bit, but we just don't happen to be using any somewhere for some reason. I don't know. Yeah, so solar, wind, hydroelectric, tidal, geothermal, nuclear, biofuels. Right. Great. All these are sources, and they could ask you this. I've seen them ask you as students before, like under the energy section, state some sources of renewable energy. Yeah, so you had to know that.
some free max, basically.
Yeah, free max. Free max.
I see.
Right? Pressure. Right? So we have 8 minutes again. Let we do some work on pressure before we end off. Right. Before we start, does anybody know the unit for pressure? Shayna, do you know the unit for pressure? Did you do pressure in school as yet? Shayna, did you do pressure in school as yet? Nah, not here, Shayna. Well, Jada and Jada, you're not in school, so I can't ask that.
Oh, sorry. So sorry. I hit the phone. I was my device. Yes. What you
Okay.
asked me? Sorry.
What is the units for pressure? Did you do pressure in school as yet?
We did it, but we wasn't supposed to do it, so they didn't teach it. But I think we got no son.
Okay.
Oh
Well,
my goodness.
let me
Yeah. The units was Pascals. Pascals. If I pronounce that correctly, am I? I was
yeah, you're good.
right. Yeah. Okay.
Right? So the formula for pressure is force over area. That's what pressure is. Right? And Shina, if I ask you what are the fundamental units, what would you tell me? What is the fundamental units?
It would be Newton, like the newtons over meter squared.
Right? So Newton per meter squared. Nice. Yeah. Okay. Right. So pressure. Pressure is simply defined as force acting per unit area. And the formula in units is pressure is equal to force over area, and pressure is measured in pascals, right? See, PA means pascals. And the fundamental units are Newton per meter squared. Why? Because we measure force in newtons and we measure area in meter squared. So it makes sense, right? So pressure is simply defined as force acting per unit area. So I want you all to just copy this down. All right, do you all have the definition and the formula copied down already? Well, guys,
Yes, sir.
Shayna, do you have it copied
Yes,
down? Jada?
Yes, I do.
Okay, let me run through a little thought experiment, right? What do you think would exert more pressure? A pin or a pencil? Curious. Which one would exert a greater pressure? Let me just say applying the same force on both. Which one would exert a greater pressure? A pin or a pencil? Jason, what do you think would exert more pressure? A pin or a pencil? And you're applying the same force on both, right? So imagine you have a pin and a needle or a pin.
And a needle, like pen.
Obviously, this one would apply a lot more pressure, right?
Yeah.
Yeah. And the reason for that has to do with the surface area.
Size. Well, yeah.
The area, yeah. The area. If you look at the formula is, Jason, tell me, what's the formula? Pressure is equal to,
So
is
pressure is equal to
you had copied
it
on it,
is,
right?
the pressure, no? Yeah.
Yeah, the formula is there. Pressure is equal to F over
Yeah.
E,
Oh, area. That's the way.
right?
Yeah.
Area. Let me give you an example, right? Let me just say we have a force of 20 newtons, right? And we have two examples, right? We have one where the area is 10 meters squared, and then we have another example where the area is 1 meter squared. So we have two scenarios. Let's find the pressure for this one. right? And the force for both of them is 20 newtons. So, Jadon, the pressure for this example would be F. F is 20 all over the area. The area is 10. So what's 20 over 10?
Wait, so you call me or you call Jada?
I'll just say
Oh,
Mr. I'll say Mr. Williams,
20 over 10, that's 2.
right? So that'll be 2 pascals, right? The unit pressure is pascals, PA. What if I were to use scenario 2? My force again is 20. What is my area in this time?
In scenario 2,
Yeah.
1,
What's 20 over 1?
20.
And my unit of pressure is
That's PA.
pascals, right?
Pascals.
Which one exerted a greater pressure? Which one had a greater pressure? The one with a larger area or the one with the smaller area?
One really small area.
Correct. So we can make a statement, right? We can make a little statement. Right? So the pressure and area are inversely proportional. When I see inversely proportional and thing, anytime I see the word proportional, I should remember Hooke's law, F is equal to KE. That should come to mind. Because remember, the force was directly proportional to the extension. Them things should come to mind. But Jadon, do you understand why I'm saying the pressure and area are inversely proportional? What
No,
does
you
that
can
mean?
explain.
All right. If two things are proportional to each other, it means that if one increases, the other one would.
Decrease.
If two things are proportional to each other.
Oh, well, they will both increase then.
So what do you think inversely proportional means?
If one increases, the other will decrease.
Exactly. And in this case, if I were to drop the area, what is increasing?
The force.
Nah.
Um, um, hold on, I guess it just.
Okay, do guess.
If you were to drop the area, then what would increase?
Yeah, look at this example and do guess. Figure it out. Look at the example.
The pascals.
And what is pascals?
The
What's pascals stand for? Like what is it? What does it measure? It measures the what?
I was guessing like
Do guess.
before.
Do guess. Do guess.
Just now I didn't note the word.
Everything right on your screen.
The pressure.
The pressure, right?
Right,
Pressure.
yeah.
Yes. So Jadon, if I decrease the area, what is increasing?
If you increase the area, that's what you said.
If you
Or if decrease
yeah, if
the
we
the pressure.
right. So watch in the first example. So
Mhm.
first things first, Jadon, in this example I give you, the force is the same for both, right? The force is the same for both.
Mhm.
Right? Force is the same. Now, area, I told you the area was 10 here. If the area is 10 here, we saw that the pressure was 2. Then I told you the area was 1. If the area is 1, what the pressure is? 20, right?
20.
So when the area goes down, what happens to the pressure?
The pressure increases.
Right. So that's why I'm saying pressure and area are inversely proportional.
Right.
And let me write that in English. So inversely proportional, that just means when area decreases, pressure increases. Yeah. Right?
Yeah.
So let's do this example here, shall we? Oh, so this is a question I could ask Khalil quickly. Why does your body exert more pressure on the ground if you stand on one foot?
Because your why does your body exert more pressure if you stand on one foot? Because the weight of your body is pushing down on that said one foot.
You're not wrong, but I want to hear it in terms of the formula. Like pressure is equal to force over area. Like I want you to tell me it in terms of like pressure and area. Like what's gonna happen?
Well,
So when you stand on the ground with both feet, I'm not saying both feet, right? Both feet. Isn't the weight of your body distributed, right? Through both feet? Like the area about which your weight is being spread out is over your 2 feet. Yeah.
yeah,
But when you stand up on one foot, does the area increase or decrease?
the area decreases.
Right. Because if you stand up on both feet, then your weight would be spread out over the combined area. So the area of your left foot and your right foot. But if you stand up on one foot, your weight will only be able to spread out over the area of 1 foot. So the area is less. Make sense?
Yeah,
And if the area is less, what increases?
the pressure.
Exactly. Great. Right. All right. So, Jira, you able to help me with this question? This is the last question for today. Can I hear in Jira? Um, Jiran, your name's something close enough to Jira. I will ask you instead. All right. So, Jiran, read the question.
Both blocks are the same mass, 60 kilograms. Block B is the same as A, but put to stand at a different position. Even though the force weight of both blocks would be the same, the pressure will be different because that force is acting down on two different surface areas.
Did you understand what I just read?
Yes, basically saying is that the both both blocks have the same mass, but the force is different because of how it's laying down. So block A is like laying down flat on the bigger face of the object. So the force would be spread out, and while block B is laying down on the smaller face of the object, meaning the force would be heavier.
Okay.
Okay.
The force is not changing. The force is not changing.
Oh well, yeah.
Because think about it, right? Both of them have the same mass. Remember, force is equal to mass
I mean,
times acceleration. So the force is
yeah.
not changing. I can guarantee the force is not changing. You have the concept, but
And just say pressure.
you're saying a bit wrong. So let me try to tighten up what you're saying, right?
Mhm.
So we understand both of them have the same mass, right? So let's find the force or the weight. Same thing. So F is equal to mass times acceleration, right? What is the mass that's given to us?
The mass is 60 kilograms.
What is the acceleration due to gravity? Because we're on it. What's acceleration?
What is the acceleration you asked?
Just like gravity.
I was supposed to ask you that. You said 10 last time. Is it always 10 in this formula? Or
Most
no?
times, yeah. If you
Most
see them, if
times?
you don't see them specify, use
Mhm.
10. If they do specify, they will say 9.81. Either
Right.
9.81 or 10.
Okay.
If they don't specify, they cannot penalize you for using either one. But if they do specify, you'll have to use what they tell you to use, right?
Okay.
So F will be equal to 60 by 10. 60 by 10 is 600. And what's the units for force?
The units for force. That's me. The unit or
Unit.
the unit N.
Yes, N. So 600 N. N means newtons. Newtons, by the way. That's what N means. All right. So the force on both of them is 600 newtons. So the statement that I made that the force would be heavier. Okay,
Okay.
first of all, you can't say force is heavier. You can say mass is heavier,
No, no,
right?
so now I say I know I went wrong. I was supposed to say pressure, not force. I realized I did because they basically said how the mass is the same and um and even though the force of the weight of both blocks would be this. They literally said it in the question, so that's why I say I had mixed up force and pressure. So that's my bad.
Mm-hmm. Yeah. And
But I
and
understand where you explain it to me as well.
and but there's something that you're missing. Now, I feel like you understand it, but
Mhm.
to write it in like the physics terms, cannot it kind of unfamiliar to you. But you understand the intuition, like it makes sense to you. I understand. So just remind me, what was the formula for pressure?
The formula for pressure is F over A. So
F over A.
force.
All right. Okay. So Jadon, the
Mhm.
force in both of the in both of these scenarios, is it the same?
The force of the both blocks.
Yeah.
Yeah.
Yeah, it's the same, right? Because force is mass times acceleration, right? Both of them have the same mass, so it's gonna have the same force. So as you can see, both of these blocks are pushing down with a force of 600 newtons. We can see that. The only difference, Jadon, is that the area for this one is what? More or less compared to this one?
More.
More. So the only difference here is area. So let's find the area of block A. Area for block A. What would the area for block A be?
The area for block B is
Block A. Block A. So this is the area we're talking about. So when I say area, I'm talking about the face that lies flat on the ground or on whatever it is.
it'll be 5 by 2 or 5 by 2.
5 by 2, yeah, yeah. 5 by 2, right? Perfect. That'll be 10. That'll be 10 meters squared. Okay, so that's the area for block A. Let's look at the area of block B. Area for block B. So tell me, Jalen, what would the area for this be? For block B.
The area for block B would be 3 by 2.
3.2 or 3 by 2?
3 by 2.
It's 3 by 2.
Yo,
So that'll be 6 meters squared. Right. So Jalen, the force is the same, right? But the area is different. Which one has a smaller area?
block B.
So which one will exert a greater pressure?
Block A. No.
What's the relationship? What happens? What's the relationship between area and pressure?
To here. Sure.
If I decrease the area, what happens to the pressure?
It increases.
Right. So which one has a smaller area? A or B?
Block B. Block B.
Block B. So which one will exert a greater pressure?
B.
Block B, right? Good. So let's test that out. Let's actually find what the pressure is. So the pressure for A will be equal to its force. The force here is 600 all over the area. The area here is 10. So what's 600 over 10?
60.
Right? And where's the units for pressure?
PA.
Right? And what does that stand for?
Pascals.
Let's find the pressure exerted by block B now. So the force, again, is 600 because they have the same mass. And what's the area?
The area is 6.
Right? What's 600 divided by 6?
100.
So question, you can see for sure now, which one would exert a greater pressure? Block A or block
Block
B?
B.
Block
B.
Right? And the specific reason is because the area is
Smaller.
less. Yeah, area
Or
is
less. Yeah.
right. So let's write a little statement here. Block B would exert a greater pressure right? Right. So block B would exert a greater pressure compared to block A because the surface area of B is less than so Jadon, the specific reason you'd have had to talk about the area. So block B would exert a greater pressure compared to block A because the surface area of block B is less than the surface area of block A. It has to do with the area, right? If something has less area, pressure will be more. Understand?
Yeah.
Right, so that's it. So next class, you're gonna finish pressure. And we could potentially start heat. Great, fun. Selma, right? Sheena, did you start heat yet in school?
Heat, no, sir.
No? Okay. What are you doing
Mm-mm.
right now in school?
Hmm?
What are you doing right now in school?
Momentum, actually.
Momentum? Okay.
Mm-hmm.
You getting through that easily, right?
Yeah.
Okay, nice. Nice. All right, well, yeah. I hope all you have a blessed day, guys. Wait, let me give all your homework one time so I wouldn't have to wonder if I give all your homework. All right, I'm Jadon. I'm looking, I'm looking out for you, eh? I need to get the answer from you. Like, please do the homework and send it to me. Try something. Try something.
Okay.
Now being serious though, like try something. If you understand something today, don't wait and forget it to try the question. If you understand what you learned today, do it now. Right? So after class, probably do it then, like as soon as you could. You don't ever watch The Boys.
Yep. Finish that and Gen V.
Every time I see Deep, I just remember and I had to do it at aquarium too. You know the Deep with aquariums can't be trusted. Yeah.
They had to break such a good character. I don't know why they had to do that to him.
I didn't watch out The Boys, but I
Mhm.
have seen clips of the final season. Well, the last season, not the final. I believe they're working on the final season. Right?
You should
So
watch Gen V as well. That's kind of good.
okay, fine.
It's like a sub series of it.
Well, I see the last clip from Gen V, right? That's like when they had like the battle and like Marie Monroe, like she like ripped the Gale hand off, you want to see blonde hair, and then Homelander come up and like laser her.
Well, that was the previous season. We have a whole new season now. It finished like 2 weeks ago.
Okay, it was good.
Yeah, the season it was good. It was I don't know the end. It was a good build up because we actually got to see how powerful Marie was, and yeah, I like in the end it was kind of corny what her lines was, but at the to say it was a good show. It's serious. Yeah, I believe they're working on our next season because they can't just end it just so. That would make no sense.
Nah, it wouldn't make sense. But yeah, she pretty powerful. I really want to see the fight between Billy Butcher and Homelander because he getting like these like weird tentacle powers.
Yeah, I don't know if it was
Yeah, you see like how he just KO human.
rest in peace, Victoria.
Yeah.
She was such a good girl.